Hello and welcome back to Math 121. This is a video over section 2.1. We're going to be talking about functions and their graphs. So our objectives today, we want to be able to find the domain and range of a relation, determine whether that relation is a function, determine whether a function represents, or an equation represents a function, evaluate functions, graph functions, do the vertical line test, obtain information about a function from its graph, identify a domain and range, and then identify intercepts. So let's talk quickly about a function. So a function is a special type of equation where for every x, value, there is exactly one y value. Okay, so that by definition is what a function is. Okay. Let's think about this. Oftentimes we use the word x value, okay? We can also use the word input, okay? We can also use the word domain, okay? So all three of these words mean the same thing. If we say a y value, okay, we often call that an output. Okay, we can also call that an element of the range. Okay, so all three of these things mean the same thing. Okay, so I just wanted to have that on there because typically, you know, the definition they use the word input and output, but I want you to know that an input is the same thing as an x value, same thing as domain. Output is the same thing as a y value, same thing as your range. Okay, and what I want you to do. A function is a special type of equation where for every x value there's exactly one y value. Computers are based off of this concept. Okay, so computers are based off of this concept. Okay, and so I want you to think about it. When you press a button on a computer, all right, that's your x value. That's your input. Okay, and if you've ever studied computers, you use the word input, output all the time. So you press a button, that's like your x value. The result on the screen, okay, whatever happens, is your y value. Now think about it. You know, only one thing happens. All right. You know, when you turn on your computer, or let's just use a remote control. When you hit the power button on your TV, the TV turns on. Okay, it doesn't start like changing channels automatically and adjusting the volume automatically. It does one thing. Okay, so when you press a button, one thing happens. Okay, and that's the result on the screen. So one thing happens. Okay, and so that's kind of a cool thing. So without the concept of a function, all right, we wouldn't have, you know, computers basically. So you can thank the concept of a function for all those fun things you have on your phone. Okay, so let's also talk about a little bit of notation. Okay, so notation. So remember, we have special types of equations that are either, you know, that for every x there's one y value. So what I want to do is write this out. I want to write out the equation. Okay. Y equals 3x plus 1. Okay? Now what I'm going to do is turn this into function notation. So function notation would look like this, where I would say f of x is equal to 3x plus 1. Okay? These things are the same relationship. Okay? My input is x. Okay? My output is y. Okay? Now, but here's the thing. All right? Y and f of x are the same thing. So y and f of x mean the same thing. Okay? And what we're going to do is we'll talk about, the difference between, why we use function notation and how to read that, okay? All right, so let's just jump in right here and let's talk about this first problem where it says find the domain and range of the relation. Now, before we even move on, a relation, okay, because we were using that word quite a bit, relation is the relationship between x and y, okay, or your input / output, okay, or your domain and range, okay, so that's the relationship. Now, a relation, we can identify those as functions or not. So on this first part, it says find the domain and range of this relation. So when I write my domain, okay, of this relation, okay, I'm going to list my x values. Okay, and that's simply it. All right, so I'm going to get this. And I put a little squiggle to show a grouping of numbers here. All right, so my first number that we're going to get, we have 0, 10, 20, 30, and then 40. Okay, and that is my domain. All right, if I wanted to list out my range, okay, this means I list my y values. All right, so if I list my y values, I'm going to get 9.1, comma 6.7. I'm going to get 10.7. I'm going to get 13.2, and then 21.2. All right, so those are the elements in my range. And this is just one way to do it. Now, if I wanted to do it another way, which sometimes I often do it like this, I just list out my numbers. My domain would be, 0, 10, 20, 30, 40. My range would be 9.1, 6.7, 10.7, 13.2, and 21.2. All right, so it kind of just depends on how you want to write it. If I'm simply just listing out my domain and it's a set of numbers, I usually do it like this, okay? But on this part, parts A and B, where it says determine whether each relation is a function, then I usually write it like this, okay? And so what I do is this. I write out my domain, okay, and then my range, okay, like so. All right, and I'm going to list off my domain. So my x values, 1, 3, 5, and 5. So 1, 3, 5. Okay, now I don't need to write 5 twice, okay, because that's redundant, all right? And I do not hail from the Department of Redundancy Department. All right, so but let's list out our range values, okay? So I've got 2, 4, 6, 8. Who do we appreciate? All right, so here's what I got. Now what I want to do is I want to say that 1 maps to the number 2, okay? So when x is 1, my y value is 2. All right, now when x is 3, y is 4. Now here's the issue. Okay, when x is 5, we get 6, and we also get 8. Now the issue is that this is not a function, okay? And the reason is because, remember the definition is for every x there is exactly one y value. Here, x, when x is 5, I get 2 different y values of 6 and 8. Therefore, it's not a function. So it's not a function, and one of the ways I can tell by looking at a list of points is that the x values can't repeat. Can't repeat. The y values can, all right? Y values can. So don't worry about that, all right? All right, so now let's take a look at problem number, part B. All right, so same thing, domain, domain, I'm going to put a D. And I'm just going to list my numbers. So I got 1, 3, 6, and 8. And then my range values, I've got 2, 4, and 5. Okay, and 5 and 5. So a 5 pops up twice here as my y value, and that's okay. Okay, so 1 maps to 2. 3 maps to 4. 6 maps to 5, and 8 maps to 5. Okay, now the cool thing is even though the y value does repeat, okay, 6 and 8. So think about this. Like, there's a number of ways on an iPhone to open a picture or open the camera up. You can do it from the control center if you swipe up on your phone. You can do it by simply swiping right on your phone or from the right to the left, or you could just simply open up the app. So there's multiple ways of achieving the same output depending on your input, okay? So, that's how I can kind of explain why you can have multiple x values go to the same y value, okay? All right, now let's take a look over here where it says solve each equation for y, then determine whether the equation defines y as a function of x. So what I want to do here, I've got this equation, 2x plus y is equal to 6. So subtract 2x from both sides, okay? And I've got y is equal to negative 2x plus 6. So this is a function, okay? All right. Y is a function of x. Now the reason is because, and it's kind of hard to explain, but the reason is because when y is isolated, okay, when y is isolated, okay, we can plug in x values. Okay. Now there's nothing that will cause multiple y values. Nothing will cause multiple y values. Okay? And that's kind of an interesting thing. All right, so let's take a look at part B, because part B is actually not a function. Okay, so let's look at see why. So if you have this equation x squared plus y squared equals 1. So I'm going to subtract x squared from both sides. Okay? And then I get this statement, y squared is equal to 1 minus x squared. Now, when I solve this equation for y, okay, I'm taking y and I'm squaring it. So what I have to do is I have to take the square root of both sides. Now, remember, when I apply the square root and I'm solving an equation using a square root, what happens is I have to account for something. I have to account for the plus and minus square root of 1 minus x squared. Okay? Think about what you get here. This is not a function. Okay? Not a function. And here's why. Because when I have this equation the way that I have it, I've got two equations here. I've got y equals positive square root of 1 minus x squared, and I have y equals negative square root of 1 minus x squared. Okay? Now let's just think about something here. Okay? Let's just think about the graph of each of these. Okay? So let me graph both of these. Okay, so now that I've graphed both of these, and what we actually get is a circle, okay? But we get the top part of the circle is in red, which is my positive square root, and then my bottom part of my circle is in blue, okay, and that's my negative square root. So let's think about what happens here. If I plug in, say, like 0.5 in for x, I'm plugging it into one equation, okay? When I plug in 0.5, 1/2, and I know this, but you don't. Just trust me that the y value is the square root of 3 over 2. Okay, I know that from my trigonometry. But if I plug in 1/2, okay, I also get the negative square root of 3 over 2. Okay, and so I get two x values that happen. Okay, I get two y values when x is 1/2. That's why we don't have a function. Now, if I'm going to go over here and let's just graph this equation. All right, y equals negative 2x plus 6. Okay, and when I look at this graph, what I notice is that, for there's not multiple values. Whenever I plug in a single x value, I'm going to only get one y value. All right, so one of the ways that I get this is, that this is not a function is because I have multiple equations that will yield me the same value for y. When I plug something in for x, I also have to count for both equations, okay? So that's why I get that. All right, so now the big thing, evaluating functions. Let's come up over here and let's talk real quick about evaluating functions, all right? Okay. So to evaluate functions. All right, and I want to do a couple easy ones before we jump into the hard ones. When we evaluate functions, what this means is that we plug numbers in for x and determine what y is. Okay, so determine what y is. Okay, so let's think about just having this generic function. Let's just do f of x equals 3x plus 1. All right, something like that. Okay, what I'm doing when I'm evaluating a function is this. I'm taking f of, say, oh gosh, let's just plug in the number 2, okay, in for x. Then I'm going to do this. I'm going to do 3 times 2 and then plus 1. All right, so if I do f of 2, that's going to give me 6 plus 1, so then f of 2 is equal to 7. Okay, and what I'm doing is I'm evaluating, okay? And so when I write this, 2, all right, so when I write f of 2, that means that I'm plug in 2 for x and get y, okay? That's what that means, okay? And so when I have this answer down here, f of 2 equals 7, this represents a point on the graph. This represents that I have, when x is 2, my y value is 7, okay? Now again, this is in function notation, all right? To show a point, this is how I would write that in function notation. Okay, if I wanted to write a point, just any other way, I would just write it as 2, 7, okay? So that's the idea. All right, so that's what I'm doing. All right, so let's go back down to the bottom of the page, okay, and it wants us to evaluate this function. Okay, now here, it's a little bit different, okay? So if f of x is equal to x squared minus 2x plus 7, in part A, I want to find f of negative 5. So if I find f of negative 5, that means I'm going to plug in negative 5 into x of my equation and see what I get for y, okay? And so once I do this, okay, f of negative 5, negative 5 squared gives me positive 25. Negative 2 times 5 gives me positive 10, and then plus 7. So then f of negative 5 is equal to 25 plus 10, which is 35, plus 7. F of negative 5 is going to then equal 42. Okay, so what I have is f of negative 5 is equal to 42. So what this means, and this is my answer. Okay, but what this means is that when x equals negative 5, y is equal to 42. All right, and I can write my answer like this: negative 5 comma 42, and that's it. Okay, and that's my answer. Okay, let's take a look at the next one. The next one's a little bit trickier because I'm not just plugging in a number, I'm plugging in an algebraic expression. So if I'm finding f of x plus 4, I'm simply just going to plug in x plus 4 where I had an x. So I'm going to replace x with x plus 4 squared minus 2 times x plus 4, and then plus 7, okay? And let's evaluate this. F of x plus 4 is going to equal, if I take x plus 4 and square it, that's x plus 4 times x plus 4. So by multiplying it out, I'm going to get x squared plus 8x plus 16. Here I'm going to distribute my negative 2, and so I get minus 2x minus 8 plus 7. So now let's combine our like terms. So f of x plus 4 is going to give me x squared. Okay, 8x minus 2x gives me plus 6x. 16 minus 8 gives me 8, plus 7 gives me 15. So what happens is that when I plug in an expression into a function, I'm going to get another function, okay? And I'm going to get x squared plus 6x plus 5 plus 15, okay? And that's what I would get. All right, let's take a look at the next one. If I plug in negative x, and this is going to be important to do this later on, what I'm going to do is I'm going to replace everything that we had in my function with a negative x. I'm going to do negative quantity, negative x squared, minus 2 times negative x, and then plus 7. Okay, now when I take negative x and I square it, okay, that's negative x times negative x. It's going to give me a positive x squared, so nothing really changes. Negative 2 times negative x gives me plus 2x and plus 7. Okay, so again, if I'm not plugging in a number, okay, I'm just plugging in, another expression, and then we get another function as a result, okay? And that's the idea. All right, so let's take a look at some graphs of functions. Okay, on the next page, it says use the vertical line test to identify graphs in which y is a function of x. So the vertical line test, okay, so let's talk about this. So the vert line test. If you put a vertical line on a graph, okay, then it is a function if the line passes through exactly one point at any point. Okay, well, it passes through one point. Okay, and let me show you what I mean by that. All right, so if I come over here and look at part A, I'm going to create a vertical line. Okay, so here's my vertical line. It's mainly vertical. And so if I move this graph, if I move this line across my graph, what I notice is that my vertical line will only hit one point along the graph. Okay, so if I put it right here, okay, notice what's happening. I'm just touching the graph at one point. Okay, if I, oh dear, trying to manipulate this. Okay, what I can do is if I move that around, notice how this graph is only going to hit at one point. Okay, now that's not going to be the case for part B. Okay, so in part B, if I do the vertical line test on B, here's what's going to happen. If I move this across, boom, all of a sudden I have 1, 2 points. That is not a function. So this is not a function. Okay. Over here, this is a function. So is a function. Okay. Part C, all right, if I do that one, let me draw my vertical line. And so if I move my vertical line across, okay, it's only going to hit at one point. So yes is a function. So is a function. Okay, and then part C, if I draw a vertical line, this one isn't going to work. And my lines aren't exactly, the most vertical, but we try. So we move this across, and what we notice is that this is going to intersect the graph twice. So not a function. All right. So remember, for every x, there is exactly one y value. All right. And that's how we use a vertical line test. All right. What I want to do here is take a look at this problem. All right. So use the graph of f in figure 2.9. Okay, on page 219 to find f of 5. Okay, for what value of x is f of x equal to 100, and then estimate the minimum average T cell count during this stage. And all I want to do right now is take a look at parts A and B. Let's kind of ignore part C for right now. If I wanted to find f of 5, okay, using this graph. So f of 5, this is my x value, okay, and I need to find my y value, all right? So when x is 5, okay, I come down here to my x-axis, x is 5, what's my y value? Okay, so I'm going to plot this point right here, and then what that means is that when x is 5, f of 5 is equal to 400, okay? And that's what we would get. All right, now then it asks, for what value of x is f of x equal to 100? So when I look over here, so f of x equals to 100, then x is equal to what? Okay, what this means is that my y value is 100, and I want to find x. Okay, so what I'm going to do is I'm going to come over here and I'm going to find 100, which is right here, and I'm going to follow that across all the way until I get to my value. All right, and so here, all right, I have this value of 9, 100. So my x value is 9 when my y value is 100. Okay, and so I have that value here. All right. The other thing, I'm only writing here that this is the point 5, 400. Okay. All right. So now, all right. So pretty simple. All right. We're just looking at the graph, identifying what my x values and y values are. Now the difference is that we're just writing it differently. Okay. We're using this concept of function notation. All right. All right. So now what I want to do is talk about my domain and range for each graph. Now, when I'm doing this, when I'm identifying domain and range, I'm asking the question for domain, where do I have x values? Where do I have x values? When I'm talking about my range, I'm asking where do I have y values? So I'm going to go through these, and we're going to talk about this, okay? And what I want you to see here is that on this graph, we have a part of a graph, okay? We have this little half circle and then a line, okay? And what I have on each of these are points, okay? So I have points along this graph, okay, over a certain area, okay? And all of those points contain x, y, all right? Now, the question is, all right, for my domain, and here's how I write this, okay, where do I have x values? And what I do is I start on the left, okay, and let me get a highlighter out. So let me do domain in red, actually, domain. Okay, and what I want to do is I'm going to highlight where my x values start and where they stop. Now my x values start over here at 2, okay, and as we move across, okay, we stop at 1, okay. So in between -2 and 1 is where I have x values. So how I'd write that, and you could just say that, all right. So there's a number of ways we can do this. We can just say x values are between -2 and 1, okay? So just to kind of give you an idea, all right? Now, this is technically false because we also include -2 and 1. So we're not just between -2 and 1. But how I would write that is this. I would say -2 is less than or equal to x, which is less than or equal to 1. All right, that's one way how I would do this, okay? This is called set builder notation. The next thing I would do is write this in interval notation and say bracket -2, 1, bracket, okay? And that's where I have x values. Now, let's do the same thing but for y values, all right? And so I'm going to come in here, let's do it for range, all right? So I'm going to come in here and talk about my range. And my range is where I have y values. So I'm going to come over here and I'm going to kind of shade this area and say, all right, well, my y values start here at 0 and they go all the way up until I get to 3. Okay, so my y values are between 0 and 3. Now, how I would write that in set builder notation is I would say that we start at 0, we include it, and we go from 0 to 3, and my y values are strictly in between those. Okay, now I could also write this in interval notation and say that we have 0, 3, and we include the bracket. Okay, now let's look at the next one because we're not going to always include a bracket here. All right, I'm just going to kind of run through these pretty quick. So my domain, D, all right, I usually just use the word D. Where do my x values start? Where do they end? Now my x values are here, here, all the way across this line, except for at -2, 2, I have an open circle, okay? And that's going to be kind of crucial here, all right? So same thing here. What I want to do with my domain, where do I start with my x values? And then where do I go? Okay, where do I start, where do I end? So I start at -2, but at -2 we have an open circle, so we don't actually include -2. So I would say this, that I go from -2 is less than x is less than or equal to 1. Now the reason why I put the less than or equal sign on the 1 is because we have a filled-in circle, okay? And that's why I did that. Now my range, all right, let's go and start for our y values. Now we start at -1, and we go all the way up to 2, but we don't include 2, okay? So where do we start from the bottom? Where do we stop at the top, okay? And so my range would be this, okay? My range, we'd go from -1 is less than or equal to x is less than 2, okay? Now, if I wanted to write each of these in interval notation, I would say -2 with a parenthesis, because we don't include it, to 1 with a bracket, okay? Same thing with my range. I would do bracket -1 to 2, and then draw my, do a parenthesis because we don't include the 2. All right, now over here, all right, we want to talk about where do we have x values, where do we have y values. And so if I'm talking about all the different points, let's start with my x values. I start at -3, and I go all the way to 0, okay, on x. So let's write that out. My domain here goes from -3, we include it, all the way to 0, okay, where we don't include it. Now, what's interesting is that, you know, between -3 and -2, all right, we have y values, but then here I have a hole, but then it jumps up, okay, at -2, and then we have a line, and then it jumps up. So even though I have holes here and here, I have other points that are compensating for those y values, okay? So I have points everywhere from -3 up to 0. Now my range is a little bit different, okay? My range only occurs at -3, -2, and -1, okay? So I would simply just write that my range values go from y equals -1, -2, and -3, and that would be my range. There's no other y values in between, okay? Now, writing this in interval notation for my domain, I would just write bracket -3, comma 0, parenthesis, and then to do this, I can't do interval notation for my range because I've only got a certain number of points, okay? So that's the video, all right? That's functions, introduction to functions. We're going to take a little bit more look at functions in the next video. So get started on your homework, and we'll see you in a bit. Thanks a lot. Bye.